This is a review of assignment 2. So we start off with exercise 2.1, create a class to represent a purchase price of a can of soda. So in my assignment 2 solution, I've got a project that addresses that. So here it is, and here's purchase price. So I've copied this in, and then I've added an implementation. The first part of my implementation would be to create a field to represent the actual number that is the value of the price. Then I've got a constructor that sets that to 0, and another constructor that allows the using code to specify what they want the price to be, and then a property that gets and sets the value of the purchase price. And of course, this is what I would call a transparent property. It simply returns the price or sets the price to whatever is asked. If you added some code in there to protect the purchase price from unattractive values, all the better, but it wasn't required. All right, so once you've created that, you can then go into main and create an instance of that class and initialize that instance to be 35. And then when you ask the human user to insert some money, that will be coming out of the price property of soda price. And then the rest of main is unaffected. The next exercise is 2.2, create a class to represent the cans held in the soda vending machine. So again, I've given you a skeleton, and you just add an implementation to that. So that is 2.2 can rack, and then there's the can rack class. And as you can see, we have created constants for an empty bin and a full bin, which is to say the number of cans that a bin can hold. We've created fields to represent the number of cans in a given bin of a given flavor. Notice we don't actually have a class called bin. We don't actually need one because all we're doing is representing cans as numbers. We've got a constructor that it says that the rack starts off full, and so you'll notice here that I've called fill the can rack. Now let's take a look at fill the can rack. And you'll note that what it does here is set each of those flavors, those flavor fields, to bin size. What I want to caution you against is actually putting this code here in the constructor. Instead, call fill the can rack, because obviously you have a method that does that. Let me show you what that would look like. So maybe we could just take this code and copy it, and then go back to the constructor, which is here. And theoretically, we could have just put that in right there. The problem with that is, as simple as this algorithm is, it's just 4 lines of code, one of which is instrumentation. If something needs to change at a later time, you'll end up having to change both the constructor and the method called fill the can rack, when in fact they do exactly the same thing. So you're much better off to leave that as a call to a method. So if something needs to change, it changes in one place, and the rest of the system automatically adjusts. All right, the next method is add a can of, and as you can see, we are going to convert that to an uppercase value so that it's a little bit easier to deal with in terms of our if statements. And then we have our instrumentation, and then I simply look at the value of flavor of can to be added, and if it's regular, I add 1 to regular. If it's orange, I add 1 to orange, and if it's lemon, I add 1 to lemon. And notice that we're not doing the optional part of the exercise in the solution, so it is possible to overfill a can rack. Remove is exactly the same thing with reverse logic, so we subtract 1 instead. Again, we didn't do the optional part. Fill we've already looked at. Empty uses the same sort of logic, but to do a slightly different thing, and empties out those can racks. And then here we have some of the optional code, but not all of it, for doing the is full and is empty logic. So again, we check each flavor one at a time, and the expression that we have is if the flavor is equal to the bin size, then that's our definition of full. So this expression in highlighted blue would be either true or false. It's a Boolean, so result would be either set to true or false depending upon the value of regular versus bin size. And then that result is returned. And is empty does the same sort of thing, but instead of comparing it against bin size, we compare it against empty bin. So once I've got can rack written, I would then go back into my main, and here I am instantiating can rack into soda rack, and at the end removing a can of, and in this case I've arbitrarily chosen regular as the flavor of can to remove. Now if you do the optional part with is empty and is full, that is here in the last project in this particular solution. So we can take a look at CanRack. And here we see that code being added. So when we attempt to add a can, we check first to see if the rack is full of that particular flavor. And if it is, we write out a debug statement. Otherwise, we go ahead and add the can. And with remove a can of, we do the similar sort of thing, but here we use is empty. And that's assignment 2.